The second secret of optical geometry. Consider an isosceles triangle ABC. AB is equal to AC and equal to 1 unit of measure, and BK and BK is equal to KC and equal to sine of half of angle A. Angle A1 is equal to angle A2 and equal to half of angle A. Angle B equal to angle C and equal 90 degrees minus half of angle A. D is starting point of the ray DE that is perpendicular to AB. DE is a ray of light emanating from D perpendicular to AB. And angle E is equal to 90 degrees minus angle A. And so angle E1 is equal to E2. And now we can calculate angle F. Next angle of our ray of light. Angle F we can calculate, so, and we see that is equal to angle A multiplied by 1.5. And after this we can calculate angle G, G1, that is equal to angle 90 degrees minus angle A, and hence angle Z1 is equal to 180 degrees minus angle A and minus angle G2. And then angle Z is equal to 90 degrees. It is the right angle and equal to Z2. Then point Z will be the last new point of the ray, since from Z the ray will return to G and then to F and to the starting point D, then again to E, and so on to infinity. So we again got a real constant pulsating object, RCPO, in space and time. Let's compute the length of that RCPO. DFGZ is equal to L and equal to sum of 4 summands, DE, FEF, FG, and GZ. We now express all summands by AD. It means address of starting point address. And we see that length of DE is AD, starting point address, multiplied by tangent A of angle A. And now we need next summand if length. We need for this a length of CE. And CE we get through address of starting point AD, and this is the value of CE. Now we can to calculate EF, and EF we see that is sum of two summands. One summand is depend on starting point address AD, and other summand is not depend of, from this AD starting point address. And after this we need to calculate FG, and it is we calculate, it is not so difficult. Length of FG, and we get it here. FG is equal to sum of two summands also. One of them is depend on AD starting point address, and other summand is not depend from this address of starting point. And it is equal to FG. Now we need last part of RCPO GZ, and we get GZ. It is consists from three summands. One of them is depends on starting point address AD, and two summands are not depend on the starting point address. And so we can all total length to calculate via starting point address, and we substitute instead D, E, E, F, F, G, and GZ values computed before, and we see that this length is total length. This total length is this sum, and we see here that terms that depend from AD, it means starting point address. These terms cancel each other. Also for extreme terms, D, E, and G, Z, you see here, GZ has AD multiplied by tangent A, and also DE has such a term, but here one time with plus and other time with minus, the same term, and they cancel each other. Also for extreme terms, and also for internal terms. You can see, we can see that here, and now we see that starting point address AD is disappeared. It is a universal phenomenon, this when starting point address is disappeared, and it is the universal phenomenon that we promised in our first secret of optical geometry. So we get this expression for our total length over CPO L, and after simple transformations we arrive to a very simple expression, sine A plus sine double A, and it is length of our RCPO. So it is the result of more complicated kind of RCPO. After this we will continue with more complicated forms of RCPO, our real constant pulsating objects. We continue this in next our secrets of optical geometry.